Greetings and welcome to this brief presentation on quasi experiments. And the main objective here is to provide a quick overview of quasi experimentation and the different threats that are most salient in the context of this kind of study. When random assignment isn't an option. So I'll go over first a quick review of some of the primary concepts in the course so far, mainly only related to random assignment and quasi matters. And then I will delve into some of the threats and ways to check for those. So what we have obviously in business and most orgs is lots of resource limitations, and random assignment requires a level of resources and commitment that a lot of companies just either cannot make or they don't yet understand the benefits of making that trade-off. So Shotters, Cook, and Campbell here in Chapter 5 talk about quasi-experimentation and at least how to rule out and, I should say check for, and then rule out threats to validity that arise in quasi-designs. Just inserting a quick note here, though, having said that, there is a big movement that I've heard from multiple folks who work in the program eval realm who are saying that for grant purposes, if you want funding for your program evaluation, or you're working for the government, or something funded by the government, basically the standards are tightening to the point that RA may not be an option, but it is a necessity. And so if you start working in that, in the program eval realm, you may notice this as well, that the standards are definitely going up, and so you need to know how to do both RA and situations where RA isn't feasible. Okay, so quick review. Why is random assignment so effective for generating causal inferences? Remember, it is because it equalizes the intervention group and the non-intervention group on all variables, observed and unobserved, such that the only difference between the two groups will be the intervention's effect. And so that's how we can tease apart the intervention's effect from everything else going on, the confounds, the error, etc. It equalizes error across both groups. There are several reasons that SCC delineate later, but overall that is why RA is important in a nutshell. And I know that is difficult to explain to a client, but if you can come up with some salient examples for why RA would matter, especially in the context of the project that you're working on with a client, perhaps you can persuade them that it will be a benefit. So that's something to keep in mind. A lot of people in their daily lives don't think about causation to the level that we do as scientists, and so it's up to us to do the best we can to educate them using stories. To the extent that they are interested and are willing to listen, we have some quick tools and stories on hand to do all we can to persuade them that RA is important, because there really is no other way to determine causation. And even RA has its limitations, but if there is significant financial resources being invested in the program, it only makes sense to do the best we can to try to make sure those inferences are justified and can hold up. Why is it technically incorrect to say that we validate measures? Remember, you may have heard from previous classes as well, we never validate measures. We validate measures for some use for something. So some measures are meant to predict turnover, some measures are intended to predict performance, future OCBs in the org. We have several things that measures can be used for, and a particular measure can be totally valid for predicting one outcome, and of course completely invalid for predicting another. So saying that a measure is validated is kind of a misnomer. There always should be more information attached to that. It's valid for predicting X or Y. It's valid for assessing the theoretical essence of this construct. That would be construct validity matter. So think it through in those terms. What is the difference between a true experiment and a quasi? A true experiment always employs RA, and a quasi cannot employ RA for one reason or another. So people are assigned to groups either by convenience, volunteering, or some other method that does not employ chance alone. How does a control group help rule out testing, history, etc.? Well, when we have a control group that is the best that we have, the best estimate we have for a baseline. And so we can, if we assume that testing is happening equally or relatively so across both groups, then if we have a control group, we can tease out the testing effect from the intervention effect because we have that baseline to compare it to. Now, if testing is only happening in the intervention group for some reason, that's called local testing. If history happens in one group, if an event of some kind, external event, impacts only one group and not the other, then we have a local history effect. But a control group effectively rules out these threats if they're assumed to be happening equally in both groups. So it's good to keep in mind that distinction of overall history versus local history, overall maturation versus local maturation, and I will show you an example of local maturation in a second here. A confound is a variable that makes us that how should I say this? A confound is a variable that causes us to be confused as to whether the effect that we see was actually from the program itself or if it was from another variable like the person's baseline skill, the person's maturation levels, etc. Okay, so confounds are things that make us confused about where the real effect is coming from. So how can we plan ahead and mitigate their effects? There are two primary ways we can do this, and that's through multiple testings, multiple pre-tests, multiple post-tests, which I'll talk about here in a second, and the other way is through control groups, a control group or control groups. How can we tell if they're operating in our study? We can look at the pattern of findings through the pre-tests, for example, and we can look at the patterns across the control group and the intervention group to be able to figure out if perhaps these are happening. Of course, it's probably impossible to know for sure exactly what is happening and how it's happening, but we can get a pretty good idea to be able to share with our clients. How do we deal with them post hoc? The way that you can, if you can't do random assignment, what you can do is collect the variable that you believe is the confound or two variables. So whatever you think is causing the effect, that is mimicking an intervention effect, what you could do is collect that variable and then statistically partial it out after the fact. Now there are problems with doing that, but it is better than nothing. So if you cannot do random assignment, part of our job as scientists is to surmise what are the things that could be mimicking this effect and how can I measure them throughout the study, and then later analyze that data and try to parcel it out via regression or some other method. All right, so just a couple of main concepts from Chapter 5 and then I'll wrap it up. There is a threat to internal validity that should be the most salient to you when you look at a design like this. And there are several that could be in play: maturation, testing, instrumentation. However, the most probable one is probably selection, because you see that NR there, and that means that people are voluntarily assigned, volunteer to be in the intervention group, for example, or they're assigned by convenience or some other method. So the first threat that should pop into our mind is selection. So selection is the base threat for this design when you see that NR there. Um, and as such, it provides the first layer of the threat. And then on top of it, we have selection by maturation, selection by testing, and that just means that the maturation or testing is happening in one group and not the other. So we use this term, SEC uses the term selection by testing threat. And so you'll see that, and that is just another term for local maturation or local testing. But again, selection threat is the basis of this because it's only happening in one group, and it's happening because there was no RA, and these groups are systematically different from one another based on some characteristics. Okay, so life without RA, what do we do? Well, first we do some a priori planning and then post hoc investigating to be able to identify and rule out threats. I would say that it is better to, as a scientist at least, and for our integrity, it is better to anticipate a threat beforehand, collect data so that we can rule it out, and if we can't rule it out and it is operating in the study, to be clear about that with clients or whoever wants to know. Unfortunately, it's usually not that easy. People don't want to hear negative, a lot of times negative feedback about the program. And there may be some political things involved where people, God forbid, but this does happen, where people may lose their jobs if this program evaluation does not come out in a certain way. And that's all discussed, of course, in the ethics chapter that we went over. So I am teaching you the best science, and then we have to live with and operate within the constraints of the organization to the extent that we can while still being ethical. And there's no real right and, well, I shouldn't say that. There are some definitely wrong things to do, but it's not as clear cut, I should say. But if people are interested in accuracy and interested in reality and being grounded in reality, then that is always going to entail, at least in my experience and the people I've talked with over the years, that will always entail a struggle with the available evidence that is not always fun to confront. It's not always convenient to confront. In fact, I would argue that very seldom is reality convenient to confront in life in general, right? So just keep that in mind. Program evaluators have to struggle with this a lot. And they talk about that with me, and I hear it at SciOp as well. So it's definitely something that the challenge we have in our field. And of course, every profession has its challenges. Okay, so let's say we have here an intervention group and a control group without random assignment. And we have on the x-axis observation 1 and observation 2. And over time we see the intervention group taking off, and the control group does too, but to a lesser extent, as you can see in the blue with the blue line. And of course the y-axis is our outcome of interest. So we have an intervention that is intended to increase that outcome, and what we have here is movement in both groups in the same direction. And so this is one of the more difficult ones to interpret because it is consistent with a selection by maturation or local maturation threat. And that means that people in the intervention group are maturing at a faster rate than those in the control group. So one way to resolve this or to rule out this particular threat is to do a technique that SEC talk about, and that is to plot pretest scores against the maturation variable. So on the x-axis you have the maturation variable that you have decided to collect beforehand because you were smart and wise, and you decided that you were going to rule out this threat if it chose to present itself, and it has, and so you collected age or years of experience from all your participants. Then you take your pretest scores, whatever the skill is that you're trying to increase. You took everybody's baseline, which is essential for a non-RA design, is you need some kind of baseline. And you did that, and so you put them on the y-axis. And so what you have here is what you hope to see is that these lines will be parallel, and that will show that across both groups there's equal maturation rates. And that is a good thing. But if you see, like we have here, that there are differential maturation rates, and we have an intervention group that is maturing at a faster rate, then what we have is a selection by maturation threat or local maturation. And it's difficult to tease apart that factor from the intervention's effect. So what I would do if this happened to me as a consultant, I would explain this to the client and try to ask them for a randomized study, if at all possible, to see if we could tease this apart. Or if this is an ongoing program, simply collect more data to see if this evens out. But if this is a persistent threat that keeps arising, then that could pose a confound that is pretty entrenched and difficult, stubborn, should we say a stubborn threat, that only RA will let us know what's really happening. SCC talked very briefly about some more outcomes that you could see with this kind of thing, selection by maturation or local maturation threat. And this one shows the intervention group is increasing, but the control group is not. And they say that this would be a rare finding to see no movement at all in the control group. Typically there is some kind of movement. I would say that there would be more likely to be movement the longer this time frame is between O1 and O2, because people change over time. And so they say this is relatively rare, but I would say if you got this result, that would be a good thing. I think that would be a pretty solid case for your intervention. I think SEC might disagree with that slightly, but it's certainly better than this outcome right here. I'm sorry, this one right here on slide 6. Okay, moving along, outcome number 3 is that the intervention group takes a little bit of a tumble and the control group remains stable. And I believe that the most logical explanation for this is an RTM effect, where we have selected people who are high on the pretest to be in the intervention group, maybe high potentials, and they're going to take a little bit of a dive over time, and it's going to be difficult to tease that apart from an intervention effect that went, especially if you're trying to decrease some kind of outcome. So this is an effect that may be RTM at work. All right, outcome number 4 that SCC talk about, this occurs when we have people at low baseline. So people who are very low pretest scores are selected for the intervention group, perhaps. And this is again an RTM where they're rising over time back to their average, perhaps, rather than an intervention effect. So this effect is probably more difficult to interpret than this one would be, because what it shows is that we've selected the most needy individuals and they're making improvement over time, but that improvement may have been seen even without the intervention effect, remember. That's the whole point of RTM. So in this case we'll have to think about RTM and do what we can to try to tease apart that effect, but I think that it would be pretty impossible to do that without a double pretest. So that's another solution that you could go to your client with, is if we can't do RA, can we at least do a double pretest so we can catch this upturn before the intervention does occur. And I'll show you a design that employs that strategy here in a minute. Perhaps folks in the intervention group were more motivated than the controls because they tested so low, and so they worked very hard, and so that would be a case where that motivation would be difficult to tease apart from the actual effect of the intervention. Finally, SCC say that this is the gold standard in terms of findings that you could have from a program evaluation. No threats are really plausible here in terms of RTM maturation, or local maturation I should say. And that is a crossover effect. And then they also mention, I don't know if you noticed that, but they mentioned this rarely happens in real life, that you would have a case like this, but it is something that we could hope for, that it would come out this way. Okay, so overall we have these 5 outcomes. None of them are that great because we still don't know with assurance the causality piece. However, there is a way to try to mitigate, and that is a solution that looks like this, and that is a double pretest with 2 groups. And in this case, what we can do then is we can check for maturation occurring at these 2 time points in both groups, and then across these 2 time points in both groups. And that way we can tease apart, we can get a baseline for the group's maturation levels, or maturation I guess levels, the extent of maturation that's occurring, I should say. And then we can compare that to this time frame right here, and that's going to be the critical one because that's where we have the intervention. So this is a way to get around the issues that arise from the different outcomes that I went over up here prior. So if we can add a pretest or a couple of pretests, depending on the organization's level of resources. Sometimes these observation points are very expensive to collect, and so we can't do too many of them. But if we can at least do a double pretest, that helps us to rule out some things. Now, please note that these pretests have to be matched data. So the same people surveyed here have to be matched with the same people surveyed here, and then also at observation 3. So this is called a repeated measures design, if you recall from your statistics sequence. And then what we're doing is we're introducing an intervention, obviously in this group. And so repeated measures design, okay, well I forgot what I was going to say about that, so it must not have been important. Okay, so this is the double pretest with control group. And another option that you can do is a switching replications design, and I'll let you refer to SCC for the advantages and disadvantages of this. We can talk more about it in class, but this is basically where we have one group getting the intervention, and we compare time 1 to time 2, and we want this group to do better on top because they got the intervention, and then from time 2 to time 3 we'll implement it in the next group, and then we'll be comparing. Now if we have a lingering effect of this, then what we'll have is intervention light here between time 2 and time 3 in the top group, and that's not going to be a great test of the intervention's effect here between. But if the effect of the intervention is not lingering, or these time frames are far apart, and so we have some treatment decay or whatever where it's not lingering, then that would be okay. This design is also practically nice for the client because it ensures that no participants are without the intervention. So if this is a valuable intervention that people really need or want, then everyone gets it eventually and no one is left out. And that's something that you can always say to your clients. I think it's very important to point this out from an ethical perspective. SCC talk about it as well. And that is that if you have a desirable intervention, first you need to see that if it works, right? So you need RA, and RA by definition, or even quasi experiments demand by definition that some people not get the intervention. And so there'll be a control group in which they do not get that treatment. Um, However, it's important to let the client know and think about when can the other people get this intervention if it does indeed prove effective, or at least I shouldn't say prove effective. There is evidence that demonstrates its effectiveness. So that's an important ethical issue to keep in mind, and letting the client know that if this intervention demonstrates some evidence that it is moving the dial on the outcome we care about, then we will ensure that everyone does get it later on. All right. Last part here, when to consider naturally occurring controls, so cohorts. Cohorts are a particular group of people that go through experiences together, which you all are well familiar with, and they tend to be similar to one another because, again, they're exposed to the same things and they're doing the same activities typically, and so cohorts make naturally occurring, we call it, controls. They're not perfect, obviously, because cohorts can differ, but if this is available to you, take advantage of it in the org. It's what I'm doing with my research in hacking, as I'm doing cohort analysis across different years. So when some cohorts are given a particular intervention and some are not, you can definitely use this technique. Again, remember, people in cohorts kind of have similar characteristics and experiences. And this harkens back to the point I made before, that if the intervention must be given to everyone, and that's a policy, then let's say it's impossible for you to have a current control group. What you can do is have people retrospectively talk with you about what it was like before the intervention, so you can get some kind of baseline, even if it's not perfect and you can't run an analysis on it, like a formal statistical analysis. At least you'll be able to have some kind of baseline idea so that you can report to the client. And finally, archival records. If the org, I should say, has archival data and you have access to that, then definitely consider using that for cohort comparisons. Okay, well, this concludes this segment, and overall, I would say, to just keep in mind that being a scientist is a really important job, obviously, and it's not an easy one, and it requires creativity and foresight, and using any tools at your disposal, like archival data, like any retrospective data that clients would like to give you, and bringing it all together to tell some kind of story that will be helpful to them for when they want to make decisions about the program and decisions about people in the organization.